Alright, so we're moving on to this topic which I call widgets and gizmos. How many of this are in that many of that? This is a type of situation where you're going to be applying this concept. Alright, so let me give you a really basic question which demonstrates where you'd use this. Alright, it just says how many seconds are in 4 hours. Okay, so even though I realize that most of you could figure out the answer to this problem using math that you already know how to do, I want you to get used to this procedure here. I first want to go over the fact that there are 3 separate steps that you're going to have to do. The first is what's called writing down fractional relationships. The next thing that you're going to have to do is to construct what I call the crossbar with matching diagonal units. The last thing that you're going to do is cancel out your units and finally calculate your answer. Okay, so the first step is to write fractional relationships. Okay, and even though you might not understand what this means right here, you know in general what these relationships are. Okay, so ask yourself, what are some things you have to know in order to answer this question right here? Something like 60 seconds per minute, 60 minutes per hour. So all a fractional relationship is taking these words and turning it into something that looks like a fraction. Okay, so for example here, okay, all I've done is taken this phrase here, 60 seconds per, all right, and even though I haven't written a number in there, you should realize it's also correct to say 60 seconds per 1 minute. All right, all I've done is taken this phrase and turned it into something that looks like a fraction, where one of these things is the numerator and one of these things is the denominator. All right, this is one way that you can write this, but it's just as correct to turn it upside down, where you'd say put 1 minute in the numerator and put 60 seconds as the denominator. All right, you can do the same thing for this. Okay, so I'm going to put the words or between each of these. You're allowed to use either one of these. Okay, so we're moving on to step number 2, which is to construct a crossbar with matching diagonal units. So in order to do this, we're going to be using those fractional relationships that we developed in the previous step. The first thing that you're going to want to do is to draw one really long horizontal line. Okay, sometimes this line is going to need to be pretty long, sometimes it can be pretty short. Okay, but you'll get to learn the differences between when you need a long line or a short line. What you're going to do is you're going to put a couple of vertical lines through it like this. All right, just to give you a little orientation, this long horizontal line is going to act just like the line that's in a fraction, all right? Where the things on top are going to act like numerators, the things that are on the bottom are going to act like denominators, okay? So in doing this, you can probably tell that this line has been broken up into a couple of different blocks, okay? This right here would be one block, this right here would be another block, here would be another block, and then finally this last one right here. And a way that you can think about this is to make the analogy to a train, okay? Every train has something at the front, which you can consider the engine, okay? So the far left block of this crossbar is what I'm going to call the engine, all right? And at the end of every train, there's a caboose. So when you're making this crossbar, let's pretend that you're always going to have an engine, you're always going to have a caboose, okay? Is it possible that you could have a train that consisted just of an engine directly connected to a caboose? Yeah, okay. We could have one of these crossbars where you didn't have any of these sections in the middle. It would just be the beginning and the end. Could you have one with just one car in the middle? Yeah, you could have a train like that. Could you have a train that had many cars in the middle? Yeah, you could have that as well. But there's always going to be a similarity for what you're going to find in the engine and what you're going to find in the caboose, okay? So the engine of every crossbar is always going to be the same. In the lower section of that engine section, it's always going to be empty, all right? I've gone ahead and written the word empty here, but something I do in a lot of my problems is I go ahead and just cross it out like this, all right? That's just my way of saying nothing will ever be there, all right? In the upper section of this block of the crossbar, it's going to be what the problem gives you, okay? So let's use this as an example. How many seconds are in 4 hours? So what information is given to you in that question? It's going to be 4 hours. So that's the way every engine is going to be. Let's move on to what's going to be in the caboose. The caboose is always going to have in the upper right corner what the problem is asking for. Okay, so if you read this question right here, how many seconds are in 4 hours? You can tell from this question that this right here is going to be seconds. What's in the bottom, you'll see how to set that up in a second, but this is something that's going to be common of all crossbars. All right, the engine, empty on bottom, with what the problem provides you on top. The caboose is always going to have what the problem is asking for on top. So what goes in between the engine and the caboose? All right, this is where it becomes a little bit like a game. So what you're going to need to make sure that you have is matching diagonal units. Okay, so that's going to be true here. It's going to be true here, and it's going to be true of any sets of blocks here. Okay, and this will make more sense when you see an example of it. Okay, so let's go ahead and construct a crossbar with this particular problem. Okay, so to start off, start with your horizontal line. Right, I'm just going to go ahead and put the first vertical line here. This first section right here is what we're going to call the engine. Always starts with the bottom section being empty. Okay, the top section is going to be what the problem starts you with. This is going to be 4 hours. Okay, we said that you needed to have diagonal units between this box and the one that's to the lower right of it. Okay, all right. Are there any of these that puts hours as a unit on the bottom? Only this one right here puts this unit on the bottom of this fraction. Okay, so what we're going to do is be using this relationship right here. I'm going to write 60 minutes over top of 1 hour. Okay, remember the top part acts like a numerator, the bottom part is like a denominator. This has minutes in the numerator, this has got hours in the denominator. I'm then going to draw another vertical line. Okay, same thing. We need to make sure that this unit here is going to be the same as the unit to the lower right of it. Okay, so since this is minute, we know that the unit on the bottom here also needs to be minute. So let's take a look here. The only relationships that do that are this one and this one right here. Okay, but let's think about what we're eventually trying to do. We're trying to eventually get so that the upper right is what the question is asking for. Okay, seconds. All right, we eventually want to get seconds up here. So is there either one of these that would put seconds on top? Okay, this one right here accomplishes that. Okay, so let me go back over this crossbar one more time. What we were calling the engine should start with what the problem provided us with in the upper left corner. Okay, 4 hours, because that's 4 hours in the problem. Okay, the caboose should provide us with what the problem is asking for in the upper right. Okay, the problem is asking for seconds. That's why seconds is what appears in that particular section of the crossbar. The last thing about the crossbar is that you need to make sure that you have diagonal matching units. Okay, hours is here, that matches hours there. Minutes is here, minutes is here. So now that we've correctly set up this crossbar, what do we do with it? Okay, I mentioned before that when we're doing the crossbar, the things that are on top of the line are going to act like numerators. The things that are on the bottom are going to act like denominators. Okay, so what you can think about this as is just one big fraction. In doing this, you can now think of this as just being over top of 1. All right, so this is one fraction times another fraction times another fraction. Okay, so what can we do with these fractions? All right, well, the first thing that you can do is go ahead and cross out units. Okay, well, I've got hours as a unit here, I've got hours as a unit here. That means those are going to cancel out. I've got minutes on top here, I've got minutes on bottom, those cancel out. Okay, what that means is that my answer is going to be in the units that are the only one that is left, okay, which is going to be seconds. All right, now all you have to do is think about the numeric part. Okay, all the numbers that are on top are going to be treated like numerators. All the numbers that are on bottom are going to be treated like denominators. So what do we have? Times another 60 on top, we've got 1 times 1 times 1, which is just going to be 1 on the bottom. All right, and so what does this equal? 14,400. And the units of this, it's always going to be the unit that is in the upper right corner. Okay, 14,400 seconds. Okay, and the reason that I call this process widgets and gizmos is that in order to get really good at it, I think it's good to practice with some units that just are meaningless, where you're not biased by things that you already know. Okay, here I'm just going to provide you with some make-believe statements. And so this is just a way to practice this process of how to set up this crossbar to come up with the final answer. Okay, so there are 17 gizmos in 2 doodads. There are 750 gizmos in a widget. And what we need to find out is how many doodads are in 16 widgets. Okay, so the first thing that we want to do is come up with fractional relationships. Okay, let's take the first statement here. So we can take this statement here and turn it into 2 fractional relationships. Okay, the other one is just the first one, which has been flipped upside down. Okay, the second one, we can do this. Again, you come up with 2 fractional relationships. So let's do our crossbar. How many doodads are in 16 widgets? 16 widgets is what we're starting with. Okay, the bottom is always empty. Okay, we want to have a diagonal relationship here. There's only one of these that puts widgets in the bottom, which is this one right here. Okay, we now know that we need to have gizmos in the bottom here. So there's actually 2 of these here that have gizmos in the bottom. All right, so how do you choose which one goes there? You want to choose the one that gets you in the direction of your answer. Okay, what are we trying to find? We're trying to eventually get doodads to be in the upper right-hand corner here. So in order for doodads to be there, we need to choose this relationship right here. So we fill it in this way. So let's take a look at it. This unit diagonally matches that one. This unit diagonally matches that one. Widgets is what the problem starts us with. Doodads is what the problem is asking for. Crossbar is set up correctly. So this unit crosses out with this one. This unit crosses out with this one. Okay, we know that the answer is going to be the one that doesn't cancel out. Okay, it's going to be in doodads. Okay, so the math, we take 16 times 2. That's in the numerator. We're going to have 1 times 17 in the denominator. And working this out, that works out to 1,412 doodads. Okay, so I'm going to go ahead and do a little bit more complicated of a problem here. Okay, so we've got these 3 statements right here. Here's the question. All right, one of the things I'm going to do here is use a little bit of a shortcut where instead of writing 2 versions of the fractional relationship, I'm just going to write 1 version, assuming that you can mentally turn each one of these over in your head. So the 3 fractional relationships are going to be the following. So what I did was I just took this statement right here and I turned it into this fractional relationship. I did the same for this guy and for this guy. Okay, so now we set up the crossbar. So what information is provided? 113 thingamajigs. Okay, we know that we want to have diagonal relationship among units. Okay, so if we have thingamajigs right here, we know that we need to have thingamajigs here. So which one of these does this? Okay, it's this guy right here. So I've gone ahead and put that in here. One thing I like to do is once I've used a fractional relationship, I like to go ahead and put a little mark through it, okay? You can only use a fractional relationship 1 time in a crossbar. So go ahead and put a little mark through it just to indicate, okay, I've now used that. We now know that we need to have doodads in the bottom here, okay? So do we have any of the remainder ones that have doodads in the bottom, okay? Here you don't have that, okay? So what do? This is where you need to realize that for each of these, you can have it this way, but you can also have the reverse of that. So we can put that in, okay? And again, you didn't have to write this down. You can just take a look at this and go straight to this, as long as you can mentally turn this upside down when you're putting it into the crossbar, okay? So that's that. We've now used this fractional relationship. We now need to have gizmos down here. We've now put this guy in here. So this unit cancels here. This unit cancels here. This unit cancels here. The remaining unit is widget, 5.66 widgets. Okay, because that's the unit that's in the upper right-hand corner.